All right, let's recall the definition of a function. Back to basics. A function is a relation or a correspondence where each element in X is paired with only one element in a set Y. Remember, X is called the domain, and Y is called the range, or the ones that are matched in Y is called the range. Now, a vector-valued function, which is what we're going to talk about, Rx, our domain, is the real numbers, and the set Y is a set of vectors, the range. So if we take any real number, so T is a real number, then we could write R of T, our function, as xi plus yj plus zk. So the components are x, y, and z. And then for each of these real numbers, we associate the components of R of T to obtain functions that go from x, which is the real numbers, to the real numbers. So we're going to let x be f of t, y be g of t, and z be h of t, and that makes r f of t I plus g of t j plus h of t k. And the domain of R of t is the intersection of all the domains of f, g, and h. Okay, so for an example, let's let R of t be 2t plus 1I plus negative 3tj plus tqk, and if we want to find R of 1, that's just going to be 3i minus 3j plus k, or it's the vector 3, negative 3, 1. So see, you're taking a real number to a vector. 1 gets sent to 3 minus 3, 1, and that's called a vector-valued function. And also, the limit, as t approaches a, we can take the limit of these functions, and that's just the limit of each function individually, each component of the function. And then it's continuous if, let's say, R of t is continuous at a if the limit of t approaches a, R of t exists, R of a exists, and they're equal. So that's just the normal definition of continuity. So also, if R of t is continuous, then that makes f, g, and h continuous. Okay, so those are some nice ideas there. Another definition. A space curve, because we're going to draw these curves. A space curve is the set C of ordered triples. So these are points. In the form f of t, g of t, h of t, where f, g, h are continuous on an interval I. And these right here, f, g, h of t, are the parametric equations for the curve. Alright, so let's sketch R of t equals 1/2 t cosine ti plus 1/2 t sine tj for t between 0 and 2 pi. So I have x of t is 1/2 t cosine t. Y is 1/2 of t sine t. Now whenever you're dealing with cosine and sine, if you square these things, you get pretty nice results, because if we take this and we do x squared plus y squared, we get 1/4 t squared cosine squared t plus sine squared t, and that's 1. And this is r squared, that's 1. So we have r is 1/2 t, take the square root of both sides, or if we change variables, let t change to theta, then we have polar coordinates. So we have r is 1/2 theta. And if theta is pi over 6, then r is 0.26, pi over 4, r is 0.39, pi over 3. You see that r is increasing as we go. So as we sketch this, at pi over 6, at 0 we have 0, 0.26, 0.39, 0.52. At pi over 2 we have 0.78. So we're going around. At pi we have 1.6, and then we just keep increasing as we go. So we get a spiral. Okay, well, I'm going to use Maple to draw some of these, and in the homework problems. So I want you to look at some of these homework problems so that you can see how to do your homework.